Hello everyone, and welcome to the Self-Directed Learning and Higher Education video series, module on the Motivation Transformation System, from internal drive to external connection, based on the academic courseware by Professor Shihmin Lo. For university students and graduate researchers lacking extensive professional work experience and accustomed to exam-guided learning, transitioning into open-ended industry environments creates systemic anxiety. Traditional external motivation engines fail when facing standard answer-free challenges. Over the next 10 to 12 minutes, we will examine the three structural gaps of motivation, experience, and value, the high emotional intelligence paradox, the integrated four core motivation theories, the four-stage execution SOP, the four-part interactive digital portfolio architecture, GenAI-assisted web production tools, resistance to transformation remedies, and system effectiveness metrics. Let's step into the mechanics of career motivation transformation. We begin on the top left card by analyzing the systemic career transition challenge facing higher education students. Taiwanese students have long been socialized under an external-driven learning model built on exams, GPA rankings, and standard answers. When encountering open-ended industry challenges without predetermined solutions, three structural gaps emerge. First, the motivation gap occurs when students lack internal drive for self-directed exploration, leading to passive waiting for instructions. Second, the experience gap creates systemic self-doubt, where lack of practical experience causes paralysis, making "I have never done this" a reason to avoid trying. Third, the value gap prevents students from seeing the connection between classroom learning and high-value career opportunities. The motivation transformation system provides an engine overhaul, transforming passive test takers into proactive career agents. Moving to the top middle card, we explore the structural diagnosis and the high emotional intelligence paradox. Systemic career transition gaps are not individual failures, but structural consequences of exam-centric educational design. Empirical research reveals a counterintuitive finding. Students with strong interpersonal skills and high popularity, possessing high emotional intelligence, frequently avoid independent academic tasks due to an acute fear of failure. If this sounds familiar, it does not imply a lack of capability. Rather, emotional potential has not yet found a structured academic outlet. By unfreezing passive mindsets through structured process design, instructors can transform social strengths into powerful academic learning momentum. On the top right card, we integrate four empirically validated motivation theories into a sequential intervention pathway. Self-determination theory serves as the environmental soil during weeks 1 and 2, fulfilling autonomy, competence, and relatedness to convert external pressure into internal commitment. Self-efficacy theory drives weeks 3 through 5, utilizing mastery experiences, peer modeling, and verbal persuasion to build a task-specific "I can do this" belief. Expectancy theory governs weeks 6 through 8, connecting effort to performance, performance to reward, and reward to personal value. Finally, McClellan's 3 needs theory integrates from week 9 onward, tailoring job search strategies to individual need for achievement, power, or affiliation profiles. Transitioning to the middle row on the left, we examine stages 1 and 2 of the four-stage execution SOP. Stage 1 focuses on unfreezing and empowerment during weeks 1 and 2. Instructors grant students 100% autonomy to choose target industries, eliminating the fear of making a wrong choice and producing a personal industry interest list with a 1-minute oral defense. Stage 2 expands industry cognition during weeks 3 through 5. Students deconstruct real job descriptions and map target company business model canvases, establishing a concrete macro understanding of industry ecosystems to replace vague impressions with structured competitive intelligence. In the center card of our blueprint, stages 3 and 4 translate cognition into micro-successes and continuous practice. Stage 3 focuses on building micro-successes during weeks 6 and 7. Students audit skill gaps between market demands and current capabilities, producing a skill gap radar chart and an actionable strategy through one-on-one teacher feedback sessions. Stage 4 drives practice and continuous improvement during weeks 8 through 12. Students build interactive digital portfolios, present 8-minute mock industry briefings, and embrace an agile iteration mindset, moving from version 1 draft through feedback absorption to version 2 improvement. On the middle right card, we examine the 4-part interactive digital portfolio architecture. A digital portfolio serves a double-duty function, reflecting learning growth while capturing an interviewer's attention within the first 10 seconds. Part 1 presents the home and value proposition in the first 10 seconds, defining who the student is and what problem they solve. Part 2 showcases industry trends and business model canvases between 11 and 60 seconds, demonstrating macro vision. Part 3 details career strategy and skill inventories between 1 and 3 minutes using JD breakdown tables and radar charts. Finally, Part 4 presents project evidence and iteration logs between 3 and 5 minutes, proving execution through version 1 to version 2 feedback logs. Moving to the bottom row on the left, we explore modern digital capabilities and the multi-tier web tool suite. Zero-code students leverage generative AI assistants like ChatGPT and Claude to parse job descriptions, generate structural copy, and refine personal value propositions. For web construction, Tier 1 no-code tools like Notion Share2Web and Gamma.app provide rapid AI web generation. Tier 2 design platforms like Canva websites and Google Sites enable seamless Google Drive embeds. Tier 3 technical paths utilize HTML, CSS, and GitHub pages, allowing students to demonstrate AI-assisted collaborative web development as a direct competitive advantage. On the bottom middle card, we address 6 common roadblocks in motivation transformation and their instructional interventions. Choice paralysis is resolved by selecting the top 3 least disliked industries to restore autonomy. Disconnected JD analysis is bridged through peer modeling. Fear of sharing unfinished work is overcome by sharing minimum viable artifacts to build competence through micro-approvals. Revision frustration is cured by clarifying explicit evaluation criteria to fortify expectancy instrumentality. Loss of interest is realigned with McClelland need profiles. Finally, AI cognitive offloading is prevented by requiring students to restate AI outputs in their own words to verify true understanding. Finally, on the bottom right card, we synthesize the system metrics and the 4-stage self-reinforcing flywheel. Transformation efficacy is measured across 3 quantitative and qualitative dimensions: pre- and post-course competence scores, a 90-second narrative clarity test, and iteration count tracking measuring active feedback uptake. To summarize our lecture today, effective motivation transformation requires diagnosing structural gaps, deploying integrated motivation theories, executing a 4-stage unfreeze to practice SOP, and building an interactive digital portfolio. Thank you for joining this SDL lecture on the Motivation Transformation System with Professor Shihmin Lo. Keep learning, stay motivated, and I will see you in the next module.